Okay, so to get ready for this next part, I had previously cleared S to S, student to scores, and I have now restored what the contents were. So S to S now contains the names and scores for these three students, Cal, Dave, and Ed. We saw that if you iterate through a dictionary, that by default what you get from the dictionary are the keys. So if I say for K, well, I can choose any variable name that I want. So let me say XYZ just for a change of pace. In S to S, print XYZ. And as we see, we get the keys from that dictionary. You can explicitly request the keys. I'm going to switch back to using K by using the S to S dot keys method. All right, this is what you get by default anyway. Or you can request the values by saying dot values. So for V in S to S dot values, print V, will display the values in the same order that the keys were displayed. And recall that in a dictionary, starting in Python 3.7, the items in a dictionary are always stored in order of key creation. Now, the items of a dictionary are these pairs of values. So if I say for I in S to S dot items, this is an iterable that gives me back the key value pairs in tuple form. All right? So I'm going to get key, comma, value in parentheses, that is, as a tuple from that. All right? So I have quite a bit of flexibility over how I retrieve the keys or the values or the items from the dictionary using these methods. Okay, and this slide 30 repeats one of the examples I just did. And here slide 31 shows the other two examples. If you choose to iterate through the items of a dictionary, each item is a two-tuple, as we've seen. You can use multiple assignment to conveniently break this out into separate key and value variables. So I previously said for I in S to S dot items, and I iterated through these key value tuples, but I can also say for K comma V using multiple assignment in S to S dot items and print, and V is the value. And notice that to make the output look nicer, I've thrown in a horizontal tab here to get somewhat more tabular output. Okay, so here's a nice table of the key and the value for each item within the dictionary. All right, now slide 33 coalesces something that I had mentioned before about how to create empty sets and dictionaries. Now, an empty tuple is easy because you just use an open and close parenthesis. An empty list, which I'll call a vector, is easy because you just use open and close square brackets. But both sets and dictionaries use curly braces. So the question is, what do you get if you just use an open and close curly brace? And the answer is you get an empty dictionary. Okay, so here with empty parentheses, I got an empty tuple. With empty square brackets, I got an empty vector. With empty curly braces, I got a dictionary. And to get an empty set, you have to use the construction name, the constructor name set with empty parentheses. And if you ask to see the type of SE here, now you're told that this thing is a set. All right, so that's how you differentiate both in definition and also in output between an empty dictionary and an empty set. So D displays as empty curly braces, SE displays as set and empty parens. Now, to create a single item collection, recall we also had a funky thing with tuples. If we want a tuple containing one item, we have to say comma after the item value. Because if we just use parentheses without the comma, in this case, that would simply set T1 to the int value 5 rather than to a one-item tuple containing a 5. For a list, I just use square brackets and some value. For a set, I use curly braces and a value, so that's fine. And for a dictionary, I use a key and then a colon and then the value that I want to have associated with that key. Okay, so the only peculiar, funky situations are creating an empty set, which requires you to use the constructor name with empty parentheses, and creating a one-item tuple, which requires you to remember to use this comma. Okay, so we have an empty tuple, we have an empty list, we have an empty dictionary, we have an empty set. Whoops, sorry. SE was our empty set. And we also now have a one-item tuple, a one-item list, a one-item set, and a one-item dictionary. Python also provides something called a frozenset. Now, the only difference between a frozenset and a set is that the elements in a frozenset cannot be modified at all. Whereas a set is mutable, a frozenset is immutable, and therefore if you wanted to use a set as an element of a set or as a key in a dictionary, you can use a frozenset for that purpose. Other than to tell you that frozensets exist, we're not really going to bother with frozensets. Now, we've looked at conversions for the low-level data types. We've seen that you can convert a string that's in proper format to an int, or a string that's in proper format to a float. All right, so here's 1.23 times 10 to the 5th in a string converted to floating point. We can convert an integer value to a str, and so on and so forth. We can do the same kind of thing for these collection types: tuple, list, set, frozenset, and dict. The idea here is that we specify an iterable as an argument to the constructor function, and the function will create the appropriate kind of collection from that iterable. So if I say T1 gets a tuple from this iterable, this is a test. All right, now a string is an iterable, and as an iterable, what's going to happen is it's going to be broken up into one-character substrings. Consequently, T1 is going to be a tuple of these one-character substrings. And there are 14 characters, including, of course, the empty spaces between the words taken from this iterable string. Now, if I create a set from an iterable, okay, T1 is a tuple, and therefore T1 is an iterable. If I create a set from an iterable, I'm only going to have one unique copy of each value from that iterable in the set. And the order of those items is arbitrary. So here we have ASH space EIT as the result on my system during this session for the contents of S1. Now notice when I wrote these notes that the output was produced in a different order. All right, so the order of items in a set is arbitrary. Similarly, I can create a list from an iterable. Let me create a list from the set S1. S1 is an iterable. And it happens that the list is created in the same order that I was shown the elements from the set. I can, with a list, invoke the sort method, which will sort these one-character strings in ascending ASCII order. Now, it turns out that in the ASCII character set, the space character comes ahead of all of the lowercase letters, and the lowercase letters are ordered from little a through little z. The capital letters, by the way, are also ordered from capital A through capital Z, but all capital letters come ahead of all lowercase letters. So if I were to say v1.append, well, let me say v1.extend so that I can give an iterable. All right, so here I'm extending my list by saying help exclamation mark. v1 is now going to have those one character substrings, capital H, E, L, P, exclamation mark, appended on the end. And if I now sort this list, what happens is, all right, it turns out that the exclamation mark comes ahead of the uppercase letters, and the uppercase letters, which are in ascending alphabetic order, come ahead of all of the lowercase letters, which in turn are in ascending alphabetical order. Here we're showing that you can create a frozen set from a set. Well, actually from a list, but let me create one from a set. If I wanted to use S1 as a set that I could use as a member of some other set or as a key in some hash table, a key in some dictionary, I can say FS1 is a frozen set with the same items. Now, interestingly, you'll notice that S1 came out in this order, ASH and so on. The frozen set comes out in a different order, so although the items are the same, the order is arbitrary. All of these construction functions require an iterable, and so this can sometimes be a little confusing. You might think it's obvious to be able to say, I want v2 to be a list containing 1, 2, 3, 4. That seems like an obvious thing to want to do, but the integer 1 is not an iterable, and the integer 2 is not an iterable, so I'm going to get yelled at here that this is not appropriate. The list construction function only wanted one argument, but I gave 4 individual int arguments. I can patch this up by doing 2 different things here, or probably several different things. One thing I can do is to force this argument to be an iterable by just putting parentheses around it. All right, so the outer parentheses here are for the function call, and the inner parentheses make this thing a tuple. All right, so now this is legal. The other thing I can do is to just use square brackets rather than the constructor function name to get my list directly. Okay. These collections of individual values are easy to create from simple iterables. Since a dictionary has key-value pairs, it's slightly more complicated to create a dictionary using the dict constructor function. A dictionary can be created from an iterable as long as that iterable produces so-called two-tuples, that is, a sequence of pairs of values. As one really small example to illustrate how this thing works, let me create a set of two-tuples. And this two-tuple is going, or this set, excuse me, is going to contain A as a key and 12. Also B as a key and 22. Okay, so I have now created a set of two tuples. In this current session, those two tuples were stored in the set in the same order that I defined them, whereas when I was writing notes, it came out in a different order. So I won't keep repeating this, but of course the items in a set are always in some arbitrary order. Now, when I say D1 gets a dictionary built from set of two tups, the dictionary constructor goes through that set, and for each pair of values, for each tuple in this case, uses the first item as the key value and the second item as the value associated with that key. So D1 now is going to have A as the key with 12 as a value, and B as a key with 22 as a value. Okay, so this is what the documentation says about creating dictionaries from iterables, so that the iterable needs to be for a two-tuple. In fact, the iterable only needs to refer to arbitrary pairs of values. Here I'm saying list of two stars. This is a list rather than a set. And in here we have a two-character wide string AB and another two-character wide string CD and a third two-character wide string EF. Well, it would help if I could type. I need to remember my assignment operator. All right, so now we're good. This looks very little like anything to do with set of two tups. But notice that a list is an iterable, and the items in this list are iterables that have two items in them. Each of the items in this list of two stars is a two-character wide string, and that can be split up into the first character being the key and the second character being the value. So this also will work to create a dictionary. Okay, so list of two stars is an iterable. The first item in that iterable is the string AB, and that is an iterable on two values, so it gets split up into A being the key and B being the value associated with the key. Then we have C as the key with D as its value, E as the key with F as its value. Well, these couple of examples that I showed of creating a set of two tuples and a list of two strings are somewhat artificial. It's more common that you would have two separate iterables, two separate lists, or a list and a tuple, or a list and a string, or a range and a string, or something like that. And you would like to be able to use these, respectively, as the sequence of keys and the sequence of corresponding values for those keys in a dictionary. You can zip together two independent tuples into an iterable on two tuples by using this function called zip. Let me illustrate how this works. Here we're creating, I'll just type this in and get back to you. All right, so here I have created a list V1 with 6 int values in it and a string S1 with 3 one-character substrings in it. Now, it turns out that because these two iterables have different lengths, it's the shortest one, namely the S1 string Dan, that's going to determine how many pairs of values there are in the resulting zip of these things. All right, so I'm going to say for T for tuple, because zip produces an iterable on tuples. In the zip of V1 with S1, Okay, so the first item of V1 is going to be zipped to create a tuple with the first item of S1. Then the second item of V1 with the second item of S1. Then the third item of V1 with the third item of S1. And at that point, there are no more items in S1, so zip stops trying to create any more tuples. And let me just print each of those tuples. Okay, so the loop runs 3 times. And I have the value 4 in a tuple with D, and then 12 with A, and 9 with N. And because this is an iterable on 2 tuples, from the result of that zip, I can directly create a dictionary. So let me say D gets zip of V1 and S1. Whoops, I forgot to create the dictionary. So let me add the dictionary creation part. I got a zip object rather than a dictionary. All right, so I want this to be a dictionary. And D now is a dictionary with 4, 12, and 9 as keys and DAN as corresponding values. This one in slide 41 is just a little bit longer. It's the same idea. V1 is still the same values as I had before, but this time maybe I have a tuple of student names. All right, so Al, etc. Okay, so Al, Bob, Cy, Dan, and Ed. Now, because each of these 2 iterables, V1 and T1, are 6 items long, I will get a resulting sequence of 6 tuples when I do the zip. And now I'm going to create the dictionary D1 from the zip of T1 and V1. Here I've chosen to put the student names as the keys and these numbers as values. Whoop. Okay, so here we are. So we have the student names as keys and these numbers as values for the associated with those keys. Another nice function that you can use to, among other things, build a dictionary is enumerate. Now, enumerate creates an iterable from some existing iterable in which each item of the existing iterable is paired with a sequential integer value, 0, 1, 2, and so on. So let's take a look at a simple example. I have S1, Dan, and if I enumerate Dan, if I enumerate S1, enumerate is going to return to me an iterable over tuples. 0 with the first character in the string S1, 1 with the next character, 2 with the third character, and so on. For this example, S1, that's going to be it because there are only 3 characters. But if I had S1 as a much longer string, then this enumeration would be as long as necessary. I have my tuple T1 still around with student names in it. Whoops, I just noticed I made a dumb mistake, which you probably noticed and didn't care about. V1 actually has 6 items in it, but T1 only has 5 items in it. So when I created this dictionary, I ended up with 5 items in my dictionary, and this final value 6 was lost when I did this zip. Now I'm going to change D1 to refer to a new dictionary that I'm going to create as an enumeration of T1. And so now I have the sequential integer values 0, 1, 2, 3, 4 as the keys associated with these student names. Sometimes it's useful to just have a count for each record that you're processing. Enumerate is very useful for that. If you have some kind of iterable, such as our iterable T1, this tuple of student names, you can automatically generate a record number or a line number for each one of those things by using enumerate. Here, we're stepping through all of the items in T1, and we're giving sequential integer values to each one of those records. each one of those strings in this case. Remember that I can use multiple assignment to create separate variables for the enumeration value as well as for the string value that we're reading from this tuple. So here I'm enumerating the tuple of student names T1, and then I'm using I and S to contain the enumeration number and the student name in this for loop. All right, so I print out name 0 is Al, name 1 is Bob, etc. There are other ways of creating dictionaries as well, but we're going to be content with what we've already talked about as far as this class.